All right, good evening, folks. I am going live, but I'm a minute early because I'm trying to test out some stuff just to making sure that this is all working just fine. So checking it on my phone just to make sure that the stream is working okay. So let me see. It's weird watching me on the screen like this. I should probably turn that off. Okay. All right, good evening, folks. All right. Going live, but I'm a minute early because I'm trying to test out some stuff just to make sure that. All right, so it looks like everything is working okay, and we still got another minute, so we'll go ahead and wait to see if any more folks will trickle in. If you're watching this on repeats, like after the fact, then hey, I'll see if I can keep you entertained for a minute. Back with the Mountain Dew tonight, so I am trying a couple different things out tonight. So I watched the last video. It was really dark, so I turned on the lighting above me to brighten up the room some. I also put on my headphones because I wasn't happy with the audio that was coming from the mic, at least, and I think it's coming better through these AirPods here. So yeah, we'll give it another minute here, and then we'll go ahead and begin. If you're already on, feel free to post any questions in the chat, and I'll see if I can get them answered as we go along here. So we'll begin here in a minute. I'm still not married to this platform. Still testing things out. I would like to see what LinkedIn Live is like, but I still haven't gotten approval for that, so that's why we don't have that yet. Okay. We are coming up on 30 seconds till, and then we'll go ahead and get started with this one. All right. In 10 seconds, we're going to begin. All right. Just checking out my settings again. Sorry, this is still new to me, so I'm still trying to figure out some of this stuff, but I think this one's going to be a little bit better than the last one, because the last one I didn't really have anything prepared. Not that I have like something super prepared for this one, but it's still a little bit more than the last one at least. Okay, we'll go ahead and begin. All right, folks, welcome to another live stream. This is David Hundley here again. So in case you missed the last live stream, I thought I'd introduce myself again, and then we'll go ahead and hop into this. All right, so I am David Hundley. I am a senior machine learning engineer at State Farm. I have been with State Farm for 10 years. Been working in this space for 2 years. It's been a really cool role so far. I've enjoyed the work that I've gotten to do. And so as a way to help out the community and help out others, I thought this would be a good way to support folks. So, you may have seen some of my blog posts before, and I'm definitely planning on continuing the blogging. But I thought it'd be fun to try something new. So, this particular stream tonight, we are focusing on more of a beginner topic. So if you have no what's the word I'm trying to say? Like no knowledge about what data science is, or machine learning, or artificial intelligence, this is probably going to be the stream for you. So this isn't to say that future streams will always be beginner. Like this one, I just thought it would be fun to do a beginner one just because I haven't done something like this in a while. But maybe the future ones will probably do something more advanced, probably something with AWS SageMaker. And yeah, but this first one is going to be really basic. So if you saw any of the stuff that I posted, I put out some like basic workstation setup, and I still haven't completed it. Sorry. I just got a little bit busy with some other things. But hopefully you can watch the stream, you can catch up, and then, I mean, obviously we're not going to do everything tonight. We're just going to do like some preliminary work. But I purposefully started this thing where at least prep this project to the point where I really haven't done anything at all with it. Just to give you an idea of where this might be going moving forward, let me go ahead and do a screen share here. All right, hopefully you all can see my screen all right. I am going to go ahead and open up Safari, and I am going to navigate to my personal GitHub. All right, so this is my personal GitHub account. Then what was that? Where is it at? So this is a new repository that I made. All right, so actually, let me just go ahead and do an introduction here of what I'm looking at. So this is GitHub. If you're not familiar with GitHub, this is where most people, not just data scientists, but just most software developers in general, like to upload and collaborate their code. So code is stored in things called repositories. Repositories are just basically like projects that people work on that feed a certain solution or whatever. And so, yeah, all these here are my personal GitHub repos. So, repo being short for repository, of course. All right, so if I look at so I mentioned that I started a workstation setup guide. So this is it. There are a couple readmes in here. I haven't, like I said, I really haven't done. I need to flesh this out some more. So if you did get to this point and you did install Anaconda, hopefully that should be all you needed to do, at least for tonight. All right, sorry, I'm checking my stream again because it looks like something failed out. I hope not. Uh-oh. Hold on, I'm hitting the refresh button. Hopefully this doesn't screw anything up. Okay, I think it's all still fine. Sorry about that. All right, so anyway, so this is a GitHub repo. So the GitHub repo that I'm going to be working out for this particular stream, or maybe I didn't even push it up to GitHub yet. Oh, yes, I did. So Titanic, SageMaker, BYOC. So none of these terms probably mean anything to you today, and that's okay. We're actually just going to be focusing on just like the Titanic portion by itself, without even talking about SageMaker, without talking about what a container is or what BYOC means or anything. So, but whenever, over the next couple of live streams, we'll be fleshing this repository out. So if you want to be aware of that, just note that we'll have Titanic, SageMaker, BYOC, and so you can see there's almost nothing in here right now. I have a basic README file, so if you're not familiar with what a README is, with adding a README helps your developers to understand how to best interact with your code. So let me go find one with a repository with a better README on it. So, well, I was just showing the data science workstation setup. So this is a README right here, this text right here, so you can even see it says README right here. Boop. All right. And so README is written in Markdown, and Markdown is just like a special little syntax that helps you format things in a nice way. So it's actually pretty simple. So if we look at the raw text or the raw code for this, so you can see this is the code that actually supports the README. The little pound signs indicate headers or different levels of headers. So you can see like the double pound sign here as like a second level header. Dashes do the bullets. Double asterisks are bolding text. So it's actually, there's a tiny bit of a learning curve, obviously, to Markdown, but it's pretty nice and simple to learn once you do it. And then it does these fancy things for you. So you can see here the double headers did like a smaller heading than this larger header here. And I think you can go up to 5 headers, which is just 5 of those pound signs or 5 of the hashtags, whatever you want to call them. Okay, so that is a repository, but like I said, what you came for, this is, we are going to talk about the Titanic data set. So what is the Titanic data set, you might be wondering. So the Titanic data set is a data set that a lot of data scientists like to play around with, partially because it's easy to work with and easy to understand. Not that much to it, and then also just because it's free and available. So I'm going to show you how you can navigate to that data set, and then how you download that and how we'll interact with it. All right, so to actually interact with it, it is on this site, called Kaggle.com. All right, so this is my forgot, I'm not screen sharing again. There we go. All right, so this is like the homepage if you're signed in, which don't worry if I can't remember if you do have to sign in to download this data set or not, but anyway, so we're just going to search for, actually, let's just do a Google search to make this a little bit easier. So let's go to google.com, and then I'm going to type in Titanic, if I can spell right, Titanic, Kaggle. And so it should be the first one on here. Yeah, so Titanic, machine learning from disaster. So when we're talking about that Titanic, we are talking about the Titanic that you're thinking about. So the boat that sank, the one that Leonardo DiCaprio did his stuff with in that one special movie. You know what I'm talking about. So this is a data set that contains supposedly all the people that were on the Titanic and whether or not they survived. So if you can see a couple different tabs in here. So if we navigate on over to the data section here, you can see that we do have two different data sets that are part of this. We have a training data set and a testing data set. Don't worry about what that means for now. We'll talk about that more later. And then we have what they call the data dictionary down here. So the data dictionary is basically telling us, like, what each of these things are and what they mean. And so you don't have to memorize this, but because we'll explore this here a little more in a little bit. But so to actually, first things first, we are going to download the data set. So let's see if we can find it. I honestly don't know where it's at. Oh, I didn't even know they even had like a little thing in here to be able to do this. Okay, so if you come down here and see next to this gender submission thing, and I'm not sure what the gender submission file is, and you click on this download all button, this download all button is going to download these three respective files here, the gender submission, test, and train CSV. All right, so we'll go ahead and allow, and it is downloading to my desktop right now. All right, so let me see if I can open a new Finder window. Finder. All right, so if I go to my downloads, you can see that I have Titanic in here, and you can see the three respective files. So you might be wondering, what is a CSV file? So a CSV file, CSV stands for comma separated values. And so if we open this, let's see if we can open this with text edit. So comma separated values, the reason it's called comma separated is because it is literally just a bunch of data that is separated by commas and rows. So the first row in a CSV file is generally like the columns, the column headers of the row. And then so you can see like you have passenger ID, P-class name, age, so on and so forth. And then each of the following rows after that represent a different record within the data set. So you can see passenger ID here is going to be passenger number 892, P-class is 3. This person's name is Mr. Kelly James, I think, or Mr. James Kelly, I'm sorry, and so on and so forth. So this is a CSV file. CSVs are one of the most common data types that a data scientist or a machine learning engineer works with. I would say other common files you might see are Parquet. Why am I drawing a blank on all the others? Parquet is another big one, but I'm not going to explain what that is. But anyway, CSV is definitely by far one of the biggest. So we have our data here. I don't know what this gender submission data is about. Oh, that's just got like the whether or not they survived. Okay, I'm going to ignore this one, so I'm just going to delete this file. So what we're going to be concerned with mostly is the training and testing data sets, and I'm not going to explain what that necessarily means right now, and I might not even get to that tonight. But first things first, I want to move these files to where we're going to play with them. So it doesn't matter necessarily where you want to play with these things. I just like to keep my things organized. So underneath my documents, I have a thing called repositories. So these are all my GitHub repositories. And you can see if I navigate down here within this Titanic SageMaker BYOC, which is this, oops, let me go back in here, github.com. By the way, my short link to get to me is github.com/dkhundley. I try to keep that consistent across everything, just for simplicity's sake. So, all right, so if I come into my repositories here, Titanic SageMaker BYOC, so you can see that there's nothing in here really right now, but you can see I've got a couple of empty, so these are all empty folders. So like I said, I purposefully tried to start this where we got nothing, so we can start from scratch. All right, so I want my data to be within this data folders here. So can I open up a second Finder window? Let's see. Oops, not Find Art America. So I'm going to show you how I actually navigate to my repos because I actually don't like it's kind of weird. So like whenever you first start doing stuff with this command, this is the command line interface. So this is the way that, like, I don't know, if you see hackers in movies or whatever, this is what they work with, but it's not really that like it is powerful, but it's not like nebulous or like weird or like that you can't understand it. But the reason I like to do this is because it helps me to navigate my file structures more easily. Like, so I have this alias here that if I type repos, it'll go to my repos directory. And then the nice thing is so I'm trying to navigate to that Titanic SageMaker BYOC and then that data directory. Oh wait, I already did. Duh. All right, so so I'm trying to navigate to the downloads directory. So if I go to downloads, yes, All right, so Titanic, if I could spell right, let's see. All right, and so we should see our two data files in there. So there's our two data files. So if from this interface, if you wanted to open up a Finder window, and you're on a Mac, I don't know if this is going to would work for Windows. Then you just do open period, and that will open another Finder window that contains the data here. All right, so the only thing I'm going to do is simply drag these two files over into here, and then this blank folder really isn't needed anymore. So I'll go ahead and delete that. And all right, so we have nothing on our downloads anymore, and our data has been moved to that respective repository. So, oops. All right. Apparently I didn't do my repo or my aliasing correctly. Okay. All right. Oh my gosh, I just cannot type tonight, but it's probably because you all are watching, and I get really nervous when people are watching. All right. So we are going to interact with this data set within something called a Jupyter Notebook. So if you follow the instructions to get Anaconda set up previously, then you should be able to do this next step. And like I said, this is the command line interface. So what you should be able to do is type in, here, let me go ahead and clear this out to make this a little bit easier to read. You should just be able to type in Jupyter Notebook, and then it will start the Jupyter Notebook for you in your your web browser. Now, I personally have it set up where mine automatically starts up anytime that I start on my computer, so it's already gone up and going. So if I go to localhost 8088, this is the Jupyter interface. So this is something that you might recall from my first stream. If not, that's okay. We'll get you refreshed on, or we'll get you up to speed on this stream here. All right, so again, these are my repos. If I drill down in here, I personally like to organize my things appropriately. So even though the data is in this data directory, I'm going to create my notebook in the notebook directory. All right, so to create a new notebook is pretty easy. You just do notebook, Python 3, and that's going to drop this interface here. So by default, all Jupyter notebooks are named as untitled, and we're going to change the name here to Titanic. I'm going to call it Data Exploration. Okay. Just to make you aware, so if we come back into here and we go into notebooks, so you'll see we have our notebook here now. So Titanic Data Exploration, it ends with this extension called .ipynb. So you might be curious what that is. Jupyter Notebooks used to be called IPython Notebooks. I don't know why they changed the name, but that's why the extension is what it is. So it used to be called IPython Notebook, thus Python Notebook, thus this is called IPynb, IPython Notebook, but it is now referred to as Jupyter. So this is the standard Jupyter Hub, or I'm sorry, not Jupyter Hub, Jupyter Notebook interface. There is a Jupyter Lab interface, and I think I mentioned in the last previous thing that I personally don't care for Jupyter Lab, but if you like Jupyter Lab, go for it. The functionality is basically the same. So the nice thing about a Jupyter Notebook is it is basically this space where we can interact with our Python code and our data in a, what do you call it, like an interactive sort of way. Jupyter Notebooks are not designed to deploy out to like the real world. They are mostly designed for what we call in the data science community, we either call it discovery or exploratory data analysis. So this is where at the very beginning of one of our projects, we are just looking to understand the data. We might do visualizations on the data, things like that. And the nice thing is you can do it all within this interface here. And not only can we run the code, but we can make we can write notes and stuff too. So you can see that I just have the one cell right here. You can see that my cursor is blinking on it, and you can see with this drop down right here that there are a couple different things in here. I don't know what these other two do, but Markdown, you might recall earlier, is how we make comments using Markdown. So I've changed this cell to Markdown now, and now I can make comments in it, and I can call this. I give it a header called Titanic Data Exploration, and we are just starting off with the Titanic data set. All right, and then so if I run this cell, it is going to turn into something that looks nicer. So one way to run a cell is by clicking this run button. I personally like using hotkeys on my keyboard. So if you hold down shift and then return, or shift and enter, you can see now we have a new cell above that is the markdown, and it has like this nice thing in here. So the nice thing about these, again, with markdown, you could add images, you can add mathematical formulas, all those sorts of good things. Okie doke. All right, so let's talk a little bit about Python. So Python is the primary programming language in which we do most of our data science work. Some data scientists do use R. I feel like Go is starting to become a thing, but Python is still the big one by far. And so this, like I said, this is, as the name kind of implies, Jupyter. This is a Python environment. And so the best way that I can help you to understand what Python is and some of the libraries that support Python is if you think about, like, if you got a new smartphone, whether it be an iPhone or an Android. So whenever you get a new smartphone, you get a bunch of apps installed by default. So you probably get some sort of messaging app. If you have an iPhone, it's iMessage. You have a music app. All these things come pre-installed with your iPhone. Likewise, when we have Python, we have a bunch of stuff that comes pre-done with like Python. So like there's different ways to open files. There's different ways to get dates or times and whatever. Now let's say you have your iPhone here and you want to play on Instagram or play on Twitter or play a game. What do you got to do? You have to, obviously it doesn't come, Instagram doesn't come standard on one of these. So you have to install that application. And so similarly, and consider this conceptually, this is not literally how it works, but similarly, so Python has these extra things that you can add to it that we call Python libraries. And these Python libraries, similar to like Instagram and Twitter on your phone, augments your experience to be able to do more things with Python than you could just with like plain vanilla Python. And the reason I bring that up is because in order to do most of our data science work, we're going to be using the special Python libraries and some really common ones. So, by the way, so you might be wondering, well, are you going to teach me code in this one? I'm not necessarily going to teach code. I want to necessarily more teach conceptual things. So obviously we will be doing some coding, but I think it's more important to get the conceptual understanding of things, because then you can kind of intuit moving forward, okay, like if I have this, then I need to do this, and so on. So one thing that is important, that is nice to note with Python coding, so if you start a new cell here, so this is still under coding, so this is actual Python code that you'd be writing here. So that would actually be Python code. It wouldn't be recognized or anything because it's just gibberish. If you want to add comments to your code, you just use the pound sign as well. And so this, let me be clear, this is not Markdown. This is just Python code commenting. And I personally like to comment as much as possible just because it helps make my code a lot more easier to read. So I'm going to put a comment in here, importing the data science libraries we need. Okay, and so in this case, we really only need one, import pandas. So I feel like pandas might have a name, or like why it's named pandas. Let me see if I can find that out. Because I thought it was called like panel data frame or something. Maybe not. Maybe I don't remember. Anyway, so if you think about, all right, so one other thing with these data science libraries is you can alias them to where like you don't have to type out pandas every time. So I'm going to put import pandas as PD. So anytime you see PD from now on, that is a reference to pandas. So the primary thing that we do with data sets like pandas is that this is how we interact with data in the form of a data frame. So if a data frame, actually this is just going to be easier if I load in the data. So let's go ahead and load in the data. Loading in our data. All right, so, oops, jumping the gun here. All right, so let me come back in here, cd ... open Okay, so within our directory structure here, you can see we got all these files, and then you'll recall that our data is in this file here. So we are more concerned with the training data right now, the train.csv file. And so in order to show that, so I'm going to show just df train equals pd.read csv and quotes dot data train.csv. And is that all I need? Let me check. Sorry, I never code in front of people or type in front of people, so I just want to make sure that I'm doing things right. Okay, let me cut this out because we're not ready for that yet. All right, so this little cell, all it's doing is taking that CSV file that we had originally downloaded, and now it is loaded as a data frame, pandas data frame, I should say, pandas data frame called df train. All right, so this here is an object that has our data basically in it. So if I just were to type out df train in general, it's going to show me just like the data itself. So what is a data frame? So this is a data frame. So this is basically like a table that you would see in any old Excel spreadsheet. And so you might be wondering, well, why not just do this sort of work in Excel? And the reason is because most data like this is really big. So you can see this has 891 rows. This is actually not that big. Like Titanic is pretty small. We generally work with data that ranges in the thousands, if not millions, of rows like this. And the reason we don't put it in an Excel spreadsheet is because an Excel spreadsheet is really designed for like kind of an information gathering purposes on an individual record basis. So like if you are, I don't know, doing some accounting, you want to be able to see the line items pretty clearly within your Excel spreadsheet. And within data science, we don't necessarily care about individual records. We care more about trends within data. And so as far as trends within data goes for like the Titanic data set, kind of like I mentioned before, we want to know if a person survived or not. And so we want to know all the contributing factors to whether a person survived or not. And so you can see here that we have, like I mentioned, we have 891 rows, 12 columns. So these columns are important because these are the things that we're going to be kind of messing around with in order to see if we can find a trend using machine learning that gets to this survived column. So these columns here, you can call them columns, you can call them data attributes of the data, or you can call them, as we know in the data science community, features. So these are columns, attributes, features are all synonymous with one another, I hope, I think. Okay, so you can see that we have 12 of these features here. One of these features is our predictor feature. So this is, at the end of the day, the machine learning model, we want it to try to guess this survived column the best way. So if you're wondering, like, what does this data mean? Like, some of this might be some of it's pretty, like, intuitive. So, like, name here is obviously the name of the person. But you might, and then age as well. But you might be wondering, well, what does P class mean, or what does SIBS or Parch mean? So if you come back to like Kaggle here, and you go into this data here, you might recall this data dictionary. So this is really handy to explain what each of these things mean. So if you notice in here that we have like the survival class, so you might have noticed that in the data here that you just see ones and zeros. So obviously 1 here means yes, they did survive. 0 means no, they did not. Parch here means actually number of parents or children aboard the Titanic. So if that person had like 2 parents and 1 child, then it would be like 3 people. And then same with SIB SP here. Cabin number, and then where these people embarked from. So if they embarked from Cherbourg, I hope that's pronounced like that, Queenstown, or Southampton. Why do I feel like that should be 2 words? Okay, so anyway, so that's what all these features are. So what a data scientist wants to do, let me go back to here, is they want to find a collective trend amongst this information to like actually be able to like build a predictive model around it. And so the nice thing about this data set is it's pretty small. Like so, actually, a lot of different. Let me back up for a second. A lot of the models that you work with in real life, you know, we only have 12 features here. You might get upwards of 50 features or more. Like you could have just a ton of influencing factors, and it really just depends on like how many features you want for your model. There's a lot of mathematical stuff behind that on why you would want to have more or less or things like that. So Titanic is pretty simple. We have, like I said, 890 rows, which is enough to keep us, which is enough to play around with, and then 12 columns, which is enough to do stuff with and not bog us down. Excuse me. So I'm going to check to see here if there's any questions before we're going. Like I said, feel free to drop any questions in the chat. I am monitoring occasionally. I see the thumbs up from Maggie H there. Maggie H is my wife, so thank you, wife. So as you might guess, not all these features are really going to be relevant to actually creating a machine learning model. And I'm jumping ahead still, so I apologize. So I'm a little excited. I'm trying to figure out the best way to structure this. So this is, like I mentioned, so we just typed in df train here. We can do a number of different things with this df train here if we want to learn a little bit more about the data or any of the data attributes. So just doing df train will show like a truncated version of this, so you can see the ... that kind of represents, oh, there's more stuff in between here. There actually is a way to toggle that setting to where it will show everything at once, but it's not, like I said, it's not really worth looking at everything at once. So if you just want to look at like the first 5 rows of data, so that is .head, so dftrain.head will just show you the first 5. Or within the parentheses here, if I wanted to show the first 10, then it'll show 10. Or if I wanted to show the first, I don't know, 7, then it'll just show the first 7. Likewise, so that's the first 7 rows. If I just wanted to see the last couple, then it's tail. So the tail is going to show the last 5 here by default. If I want to get a couple more, let's do 10, and then it'll show like the last 10. Okie doke. So now what? Okay, there are other things that we can look at. So I like to do a .info. So dftrain.info. This is going to show the different columns that we have in the data set. And the nice thing about there are 2 nice things about this view here. Number one is it shows how many nulls there are. So null in the programming world means that something does not exist, and that is different than 0. And the reason that's important to notice, so you'll notice here, like this H feature, so we have a total of 891 columns, but only 714 are populated, which means the other 100 or so are not populated. That doesn't mean that they're 0 years old, obviously. Like they're not 0, and we can't, and we don't want to fudge the data and say, you know, we'll just make them all, I don't know, 20 years old, because that can mess with your model. And we'll see how we handle nulls moving forward. So yeah, like I said, it shows nulls. Interesting. Oh yeah, I forgot about that. And then it also shows the data type of each of these. So the data type, so like these first 3 features here are integers. Usually objects are strings. Objects can be multiple different kinds of values, but most of the time you're going to see these are strings. And I know these are strings because this is name, and then this is gender, and then the ticket here. And then you'll also see float. So integer versus float. Integers are like whole numbers, not decimaled out at all. And then floats do have the decimal values in here. So that's interesting that age is a float. I wonder why. So let me just show the first few rows again, because now I'm curious, because I don't remember that being a float value. Okay, apparently it is. All right, so if you wanted to learn more about a specific feature, so let's say, let's pick out P class. So I think P class, if I recall correctly, is the ticket type. Yeah, the ticket class. So you only have 3 values in here, first, second, or third. So let's say you wanted to understand the distribution of like who got like the different values across these. So if I do a df train, and then so the brackets here represent like, okay, I want to select a specific column or a specific feature. So within here, I am going to select df train. What did I say? P class. So P class, And if I were to just hit enter, so you can see that it is just starting to show me some of the p-class values in here. So the one nice thing about the pandas in here is if you do a .value counts, then you can see some useful information here. So you can see here that 491 people had a class of 3, take a class of 3. 216 people had 1, and then 2 people had 184. So that's P class. Let me see what the age, if it has any sort of distribution or anything. Okay. Oh, that is interesting. So that is okay. So here's why we have a couple of float values. It's because we have some weird. I never noticed that before. Okay, so you can see that 30 people had the exact age of 24. 25 people had the age of 28, and then you can see one person had the very weirdly precise age of 92, or this guy who loves celebrating his half birthdays, Mr. 55-and-a-half-year-old here. So that would explain why there are floats. Okay, so all right, so that is those are the main couple operations that I like to look at whenever I first delve into a data set. And by the way, so I should back up. So I am a machine learning engineer and not a data scientist. There is a difference, and machine learning engineer is defined differently throughout the industry. For me specifically, that means that where our data scientists are creating a predictive machine learning model from this data and doing all this exploratory data analysis and stuff, when they get to the point where they're ready to start implementing it into production with other systems and stuff, that's where my role steps in. So that's where, my role is actually probably closer to a software engineer than it is a data scientist. So I'm not super, super strong on the data science side, but that is something I'm trying to grow and something that we're doing here. All right, so I mentioned visualizations. So if I were to do a dftrain.hist here on the age values, I hope this works. Oof. Okay, that didn't work. Okay. All right, so apparently, so I don't memorize a lot of stuff, and in fact, this is one thing that you'll find out as a practitioner is you're going to be Googling a lot of stuff. There's a website called Stack Overflow that will become your best friend. Stack Overflow is basically this question website where people can post their technical questions, and then people can go and answer them. And you'd be surprised how well supported Stack Overflow is, and then you can upvote questions like you can on, or answers to questions like you can on Reddit. So the best answers are always surfaced toward the top. Okay. All right, so I don't remember how to do a histogram apparently. Let me see if I can just Google that really quick. So pandas, histogram. So in case you're not familiar with what a histogram basically just kind of plots out data. Okay, apparently I did do it right, but maybe I just can't do a histogram on that particular column. Let me come back to my notebook here. So what can I do a histogram on? Maybe on fair? Can I do a histogram on fair? Well, no. Or maybe I can and I just don't have something installed right. Okay. Little embarrassing, but that's okay. We'll keep plugging forward. All right, so these are our data features. So the one thing that, all right, let me take a step back and try to see how I want to explain machine learning the best. Actually, let me do it with visualization, and I don't know if I'm going to be able to do it super well with a cursor. So Affinity Designer. So by the way, in case you're curious, I actually do all my own graphic design work. At one point, I thought I wanted to be a graphic designer, and I still really do like it, but I feel like it's a kind of a thankless, or not a thankless, but a difficult kind of job because it's so subjective. And it takes a lot of time. But anyway, I started off on Adobe Illustrator, and Adobe Illustrator is great, but it's really expensive because they charge a monthly fee to use their Adobe Cloud, which I think is $50 a month. Whereas Affinity Designer here, while not as feature robust, is a one-time purchase, I think, of $30. So it is super worth it. It has a super nice iPad app. So yeah, I do all of my graphic design in here. So you can see whenever I created the title cards for this, I have templates that help me do this. And yeah, graphic design is actually pretty easy because whenever you think of so this is the Titanic boat that I created. It's just simple shapes. So you can see this is just a rectangle that has been tapered in a little bit. another rectangle, circles, rectangles. And you did not come here for a graphic design lesson. So let me get back to the topic at hand. So let me go ahead and open up a new thing here. It doesn't matter what this is. All right, let me just grab my pen tool. Not pen tool. Pencil tool? Not pencil tool. Maybe I'm going to need to try out some sort of other software because this might not work. Show me. Pen. Pencil. Sorry. Why is it not showing up right? Okay, so I hope you can see this all right. This is an XY plane here, as you can tell. Or maybe not tell. Oh, maybe if I make the stroke bigger, this will help. Oh, there we go. All right, so if you consider this as an XY plane, so if you think back to your days in high school where you had to do point plotting and stuff, so where like let's say the X graph here, or I'm sorry, how do I want to explain this? So you have your, okay, so if you recall, let's say you were given coordinates here like this, 0, comma, -1, which you cannot see because I put it behind my picture here. All right, 0, comma, 1. All right, so if I wanted to plot this, 0 represents the x coordinate. So if this is the x graph here, or the x bar here, which again, my picture is in the way. So let me see if I can move myself. Oh, look at that. Hopefully that didn't mess up stuff. And if I do a y value here, so 0, 1, if these represent tick marks in here, this is kind of hard to do with a cursor. So, all right. So x represents the first value there. So because we're not going anywhere, well, actually, let me change it from 0. Let's change it to 3, 3, 1. All right, so 3, so I count over 3, 1, 2, 3, that is this person here, or this little point here. And then if I go up 1 per this coordinate, then I can map the point right here. All right, so what data science is basically looking to do is this is very, very like one-dimensional, obviously, but it is looking to collect all like different features and try to basically like hit a y value here. I am doing a terrible job at explaining this, but let's say you wanted to predict the price of a house. So where's the text tool? I haven't used this. I'm so used to using the iPad version, not using to use this one. So let's call this house price. And that is really big. All right. So let's call this the price of a house. And let's call this X value the size of the house. Or no, how much? Yeah, no, size of the house, in square footage. So let's say each of these tick marks on the x-axis represent 5,000 square feet. No, that's way too much. 100 square feet. Okay, so let's say, and then each of these tick marks on the y-axis represent, I don't know, $50,000. So as you might be able to guess, let me go back to my pencil here. Generally speaking, when you have the size of the house, then the price of the house goes up. So let's go ahead and plot it up a few points. So this house might be a little bit cheaper. This house is going to be more expensive. This one's going to be more expensive. This one's going to be a little bit cheaper. And this one's going to be more expensive. So this is, but the point I want to point out here is you can kind of see a trend going here. You can see that as the size of the house gets bigger, the price of the house gets greater. So you can see that there's kind of like a line going through here. And so basically what machine learning is doing behind the scenes so there's supervised and unsupervised machine learning. So supervised machine learning is what we are going to be focused on here. And the reason we call it supervised is because we know the predictor value. We know within the Titanic data set that 0 means that the person did not survive and the person that did survive is 1. So that would be our Y value. So we are trying to predict whether or not a person survived. And then we have in this case, house size of house versus house price, we just have the one feature here. We have the one feature that's helping to predict this y value. Now, if you can imagine, if we had a z-axis here, this would represent a third variable. Then we could have another axis point out in space. And basically, what we're doing is when we have a bunch of features like this, we are trying to use math to basically find this line here, or find a separation between the data. And so we have in this case, this is a pretty discrete variable here, so we have either a 0 or 1. Sometimes if you can use this would be more of what we call a regression problem, the house price problem, because house prices are gonna vary up and down. Like you're never gonna have all houses cost 100,000 or all houses cost 10K, things like that. So I hope this makes sense. I'm doing a horrible job explaining it, but I also didn't realize I was gonna try explaining that tonight. So let me move my pretty picture back down there. All right, so that said, these need to be mathematical in nature. So as you can see, this data, some of it can be used immediately, some of it cannot be used immediately. And then we also have to deal with the null values. And so I don't know how far we're going to get tonight, but I'll let you guess as to what variables. Well, think in your head for a second. What variables would we instantly throw out? Because there's one, perhaps two that we can instantly throw out here that are not going to be helpful at all. Can anybody guess? I'm going to check to see if we actually have any watchers. It doesn't look like we have any watchers right now, and that's okay. So the one that we're going to instantly throw out is name. Name doesn't provide us really any value at all. It's not like people who were named Cummings here did any better than people named Futrell, or people with the last name Allen. In fact, most of these names are probably pretty different. They probably don't have any commonality. So this variable here, not worth anything to us at all. So what we are going to do here is we're going to start doing what we call feature engineering. So feature engineering is when we start taking these different values and start changing them in ways that would work better for our predictive model. And so the first thing I like to do with feature engineering is just getting rid of the stuff that we know that is not going to be any good. So again, so we have dftrain, and I think if we do a .coms, it'll show us the column names. Okay, so these are all the different column names. So I want to get rid of at least the name. I'm trying to think of what else. I don't usually use the ticket. Let me go back and look to see what the ticket means. So ticket number, I don't think that there's any value in using ticket number, just because I don't know what these necessarily mean, these numbers. They don't look like they mean much to me. Actually, I've never noticed this until right now. It looks like the first well, okay, never mind. Theory's off. I was going to say the first digit looks like it matches to P class because we had actually these 0 or 1, 2, 3, and 4 here. Actually, that does hold true, but not with the first one here. So I'm going to drop the name column. I'm going to drop the ticket column. I'm going to drop cabin as well. So sometimes there are two ways to deal with nulls. Number one is to just recognize that a feature is probably going to have so many nulls that it's not even worth using. Like cabin here has so many nulls that it's not even worth using it. So I'm not even going to use this feature at all. But as opposed to embarked here, embarked only has 2 nulls, and so we can deal with that. And then age also only has 2 nulls, and we can deal with that. And we'll talk more in a bit about how we're going to deal with that. So let's just go ahead and drop these ones that we know we're not going to use. So in order to do that, we do a dftrain.drop, and then within the parentheses here, we do columns equals, and then we are going to get rid of name. We're going to get rid of, what was the other one? Ticket. And we're going to get rid of cabin. And then I think we can keep all the others. In place equals true. So in place, so that just means, so that's a good point. Actually, let me just do this. So you can see here, if I run this cell, that it shows that basically the same thing as above minus those extra columns. But if I were to show this again, dftrain.head, boom, the columns are back. And that is because within anything within Python, we're not actually, whenever we do this drop thing, we're not actually editing this object here. We're just doing it like as a temporary kind of thing. So there are 2 ways that you can kind of overwrite this thing. We could just say dftrain equals df_train.drop, and so that'll overwrite this old object here to just have like the old stuff. Or this function also has something called in place. So in place equals true. This is going to drop our columns anyway. So now if I run this cell again, you can see our columns are gone. All right, so we have a couple of columns left that we can start doing some feature engineering on. Doing a quick time check, 7:45. I don't know how much longer I want to go tonight. Might go a little bit longer. So yeah, so I mentioned that whenever we are doing the supervised machine learning, how we are trying to nail our Y value, which is our predictor value. In this case, it's going to be survived. And then we have our other features, which are our other training data. And this is generally referred to as the collective X set of data, like a capital X. So I mentioned like a Z variable here, but this is just like data science jargon where all these other columns would be considered the X data set. So what I personally like to do at this point is, even though we have all of the stuff grouped together as one data frame, I like to separate stuff out at this point. So that means X here is going to equal our df_train dot drop columns equals survived. And I'm not going to do an in place because I don't want to mess with the df_train itself. And then Y is going to equal df_train, and it's just going to be the column, the survived period. And I think I did that right. So again, don't get hung up on syntax right now because I'm just trying to teach conceptual stuff. If you really want to get into this stuff, I could, reach out to me. I'd be glad to help with pointing to you to the same learning resources that I used. So now that we've created those, so my X data set, this is, you can see that all these same values minus the survive column, and then the Y data set is only just the survive stuff. All right, so now we're ready to start doing some feature stuff. Like I said, so these features need to be in a numerical order. And I also just noticed something. There is another column that I do want to get rid of, and that is passenger ID. Passenger ID here is just like a unique identifier for the passenger. But because they're all unique, then we're not going to find any trends here. So I should have gotten rid of this one as well. Missed that. So let me see if I can go back and, oops, I add that in here. So passenger ID. I think this is gonna throw a fit at me because let me go ahead and just like basically restart here. All right, there we go. Wait, I thought I got rid of that. Yes, I did. Okay, so you can see I've got P class still. I have the gender. I have the age of the person, Civ SP, Parch, Fair, embarked. All right, so one thing I'm gonna instantly point out here is you'll notice that the gender here, or the sex column, is encoded as male versus female with string values. Again, we want these to be numerical values because that's what our machine learning mathematical algorithms need to use. So they can't stay in the form that they are in now. So the way that you do that is what we call encoding, label encoding, or will we call this one-hot encoding or not? I don't know what you'd call this exactly. I don't know if it's label encoding or one-hot encoding, but it's encoding nevertheless. So there are a couple ways we can get around this. I'm trying to think of what is going to be like the one that comes off the top of my head. There's more than one way to do things within Python. So if I'm going to do a for loop here, or an if loop, I should say. If no, that's not right. All right, I'm just going to have to Google this because like I said, I can't remember off the top of my head how to do some of these things, so I just have to Google them. All right, so pandas, change value based on condition, how to replace values based on condition. So I just go to these blog sites and will usually tell you how to do that. So this is one way how to do that. This is, I like the mask. I think it's mask that I like to use the best. df vent hip hop equals hip hop, then do jazz, in place equals true. Okay, so I'm going to copy the syntax here, just because I'm not going to remember this because I'm talking out loud. So we have x. Actually, let me just go ahead and retype this whole thing. All right, so x, which is our data frame name, and then we are going to get the sex column dot mask, and then within the parentheses here we do x again. We'll do advanced sex equals equals. So equals equals is different than just like a regular equals, because equals equals is just like comparing two conditions that are actually saying like, okay, these two equal the same thing. So if it equals male, then we want to change that. So in the example here, we're changing from hip hop to jazz. So we are going to change from male to, we're going to give it the value of 0. So it's important to note that if it's within quotes, then it is recognized as a string. If it is not, then it's recognized as a numerical value. So, and that is okay for our case. So we want it to be a numerical value. And similarly to how we drop things above, we have the in place thing, in place equals true. And I personally like to put spaces in between things just because. And then we're going to have to do the same thing for female. So I'm just going to copy this down, copy. All right, so female, if I spell that right, 1 in place equals true. All right, so if I delete this and then I run this cell, all right, so if I look at, let's just go ahead and look at the first 5 rows here. Okay, so you can see that whereas it used to show male and female for everything, now it is numerically coded as 0 or 1. So great, so that is, let me check to ensure that the data type is correct, because before it was a string value and still could be a string value. So we could do that by doing an x, we're looking at the sex, and then dot d type. D type will tell us the value. All right, so so O in this case still stands for object, and just to ensure, so d.info or x.info. Okay, so you can see that this column is still, even though they are integer values now, it is still being recognized as object. So that is something else we'll need to change. So I can't remember again how to do this off the top of my head, so we'll just do a Google pandas change data type of column. I'm pretty sure it's as type. Yep, I'm right. All right, so as type int. All right, so let me come back to here. X sex dot as type int. And I don't remember if I'm going to have to do this. Let me check. X.info, because remember, like, it doesn't hold these things unless you set them. Okay, I wonder if there's an in place on this. We'll see here in a second. So the one thing, so this is standard documentation for libraries like this. You have like the actual function itself. So this is like, we're changing the as type, and then you can change, like, it's got different options inside of here. So you could see that the first option that, and you don't have to have options select for everything, a single thing in here. I actually call parameters. The first one that we gave was the actual int type that we want to change, or the data type that we want to change to, which in this case is int. And yeah, so I'm just gonna do, I hope this will change right. So x.6 equals, oops, sorry about that. All right, so let's check to see that that changed. Okay, so that did change everything appropriately. And I think there's probably a better way to do that. Like I said, there's more than one way to do things. And I don't memorize these things because there's so many things to memorize. That's why I keep saying it's more important to grasp the conceptual concept of what we're doing here. Because then you can always Google later to figure out what you want to do. So like I knew, for example, that we had to change this value from strings to ints. Couldn't remember exactly how to do that, but I just was able to Google that pretty quickly. Okay, so let's do one more feature tonight, and then we'll call it a night. What feature do we want to do? All right, so embarked. Let's go ahead and do embarked, because embarked is an interesting one. What do I want to do embarked? I don't know if I want to do embark, because that starts to get a little bit complicated, actually. So again, we are, as you can guess, you could see that we got to do a little bit of manipulation on here in order to get these from these string characters to something else. And then we also have some nulls to deal with. So I've been streaming for about an hour here. I think I'm going to call it a night here on this one, and then we'll go more into deeper feature engineering next time. So I will go ahead and save this, and I will go ahead and upload this to my personal GitHub. And yeah, so I hope you have enjoyed this tonight. Let me check to see if you have any questions. I'll keep talking for a little bit to see if you want to, if you're curious about anything, or if you like this format, if you'd like me to keep doing this. I personally like to just do things that are fun for me. I'm not getting paid any money to do this. It's helpful for you, it's fun for me, so it's a win for everybody. So I will keep doing these as long as I keep having fun and you keep getting value from them. And of course, the one nice thing about using the YouTube stream is that you can watch this later. So if you missed it, go back and watch it again, watch it on double speed, rewind, do whatever you want with it. So please let me know if you like this, if you have any feedback, both on just like the content itself, or if you had any issues with audio or lighting or anything. I'm still trying to work some of the stuff out. I hope the room's a little bit brighter this time since I have my overhead light on. But yeah, so that's it for tonight. We will come back. We'll do feature engineering next time. I don't know what next time means. Definitely won't be tomorrow. Tomorrow is actually my birthday, so I'm going to be having some fun times with my girls for my birthday. So maybe Thursday. I don't know. Maybe Friday. I don't know. I did the last one of these I did on a Saturday. I didn't give that much notice. I'll try to give at least a 24-hour notice on some of these things. That way, if you wanted to be able to join, because a lot of people had mentioned the last one, like that I didn't give that much notice, which is true. I did give that much notice. So, I am rambling now, and we'll just go ahead and wrap it up here. I hope you all have fun with this. I hope you learned something. And we will call it a night there. I hope you all have a good night, and I will catch you in the next stream. Thanks, y'all.